Now the topic before us is a relational database model. The relational database model is a database model. It was introduced by E.F. Cobb, an English computer scientist in the year 1969. And this model was formally published in June 1970. It has since become one of the most widely used database models. A relational model is based on the idea of organizing and representing data in the form of tables which consists of columns and rows. Suppose this is the table where these are the rows and these are the columns. Suppose you are having an online site and the relational data will be maybe consist of customer ID, customer name, email or contact number. So each row here we can say that this is A, B customer name, C, D. This is the email ID of Gmail. Here it may be having Ymail. Here these are the contact numbers. So each row, that is this row, each row represents a record and each column, this is the column, represents a specific attribute or characteristic of the data. That is, each column represents a specific characteristics of the data. That is, here as the table shows the employee data, customer data. So here the this column is representing the email of each customer. The relationship between tables is established through keys. Suppose there may be some other table, say order table, where the orders placed by different customers are recorded. Here it will be order ID, then it may be order item, then it may be customer ID. So the relationship between tables is established through keys. Here you can see that here it is the customer ID in one table, customer table. This is the order table. So this table is related with this table in the form of keys. Here it is the primary key, it is the secondary key of another table, foreign key in another table. The relationship between tables is established through keys, which are used to link related data across tables. We will have a clear view of these tables when we proceed further with this course. You will understand the concept of primary key, foreign key, composite key in detail and a clear view of each of these tables so that you can clearly understand the concept in a very simple manner. Here are some of the benefits of relational model. It is easy to understand and use, flexible way of organizing data. It is very efficient way of storing and retrieving data. This is because the data is stored in the form of tables which are easy to index and search. The relational model is a reliable way of storing data. Now the key components or key concepts of relational model. Now first is tables. Tables are also known as relations. It is the essential and primary element around which the entire relational model is built. In the relational model, data is organized into tables known as relations. Table consists of rows and columns. Rows are also known as tuples and columns are also known as attributes. Each table has a unique name. For example, we may be having a table called customers table, and customers table may have different columns such as customers ID, name, email ID, address. Table represents entities or concepts in the real world such as customers table, products table, employees table, orders table, etc. Suppose many employees working on in an organization. In the table given below, the information about each employee is stored in a row or record. Here you can see that there is an employee Mukesh. He has been allotted employee ID 567. Here you can find that his date of birth is given here and his contact number is this. So this is the record about a one particular employee Mukesh. In the same way, we are having a complete record about a particular employee Rihana in some another row. So information about each employee is stored in a row. This table has 5 columns. 1, 2. Here it has 4 columns. 4 columns and 5 rows. 1, 2, 3, 4, 5. These are 5 rows. The table shows that all the records in a spreadsheet format. All these records are in spreadsheet format. A table is a collection of data organized in columns, that is fields. These columns are also known as fields. The rows are also known as records. The top row in which in the table is reserved for field names. This is the uppermost row in the table. This is reserved for field names. That is what type of information we are to add here. Here it is mentioned. We are not to write in this field anything. We are to mention or keep the record in our subsequent rows. Next, rows. Rows are also known as tuple. It represents all of the data or information about one person or entity or anything. If we are having customers table, then all the information about the customer will be mentioned in the row. If we are having employee table, then all the information about a particular employee will be mentioned in the row. Each row in the table has same structure. In the database terminology, each row is also known as a record. In the customers table, a row would represent information about a specific customer. That is information here. Information has been given about John. His customer ID has been given. His email ID has been given. Each tuple is uniquely identified by a primary key. Here you can see that this is the customer ID. This is the primary key. We will understand about the primary key in detail in subsequently. Now columns. Here you can see that these are columns. 5 columns here have been shown, and the columns are also known as attributes, which are the characteristics of the entities being modeled. It means that when we are talking about customers or customers table is being maintained, all the columns will be pertaining to the customers. If we are having employee table, all the columns will be talking about or having record or data about employees. For example, in the employees table, columns could be employees ID, employees name, age, address, salary, etc. Only a specific type of data can be stored in these columns, such as text. For example, here you can see that in the case of employee ID, here numbers have been given. In the case of name, we are not writing 1, 2, 3. We are having specific names, Mukesh, Shelly, Rohit, etc. In the case of age, we are writing the completed years. We are not writing the year in which he was born, 1970, 1st Jan, 1970 or 2nd Feb, 1982. We are not writing in this way. We are writing only the completed age in years. Here, this is the address. Here we are not writing the address 1, 2, 3, 4, 5, 6. Not pin code. We are writing the specific location or specific city or specific country or specific state in which a particular customer is residing or having office address. Then here is it is the mention of salary. Here it is in numbers 1, 2, 3, 3, 4, 5. Address may consist of text data or a combination of numeric and text data. It may be possible that in the case of address, it may be written as 1, 2, 3, say Garden Colony, New Delhi. So here you can see that these are the numeric figures, that is the numbers, and here Garden Colony, New Delhi, it is the text. So the address may consist of text only. Here you have seen text only, or it may consist of numeric plus text. Now, primary key. Primary key is a unique identifier for each table or each tuple or row within a table. Suppose there is a university or school in which a large number of students are studying. There may be many persons having the same as many students which may be having the same name. For example, we may say Mukesh. It may be possible that there may be many Mukesh in the school. Even in if we talk about a particular class, say 10th class, it may be possible that there may be 3 students having the name Rakesh. So how to recognize when the teacher wants to uh, when the teacher says Rakesh stand up, all the 3 students will stand up. So here we have to allot a specific student ID to a particular student so that the teacher or the school authorities can easily recognize a particular student. So primary key is a unique identifier for each row within within a table. In the case of customers, there may be many customers which may be dealing with a particular shop, but the customers may be having the same name. Here again the customer ID is allotted, which serves the purpose of primary key. In the customers table, customers ID column could serve as the primary key. Keys are used to establish relationships between tables. We will learn how the relationship is established between tables. Next is foreign key. Foreign key is a column or a set of columns in a table that refers to the primary key of another table. It establishes a relationship between two tables. As already told, suppose there is a table, say customers table. Here customer's ID is given, here customer's name is given, here contact number is given. It is the customer table. Suppose he place the customer's place order. Here it may be orders table. Here it is the orders ID or order date. Here may be customer ID. So when this is the primary key and it is having relationship with the order table in the form of foreign key. When the order is placed, order is recorded here, and here mention is also made about the customer ID, so that we can judge or we can verify that which customer has given the order. So this relationship between two tables, that is the customer table and the order table, is established by way of primary key and foreign key. So here foreign key serves the purpose of relationship with the another table. Here in the order table, this is the primary key so far as the order table is concerned. But in certain situations, it also happens that one primary key, that is this key, is not sufficient to uniquely identify a row. For example, in a single class, roll number is enough to find a student. That is, we may be having 40 students and each student has been allotted a roll number, say 1 to 40. And when the teacher asks for, say, roll number 20, roll number 20 will stand up. 25, 25 will stand up. But in the whole school, there may be many classes and each class may be having 1 to 40 students or 1 to 20 students. Then if we say roll number 20, there may be many students across many classes having the same roll number. Then in that case, it becomes difficult to find out a particular student. So in the entire school, finding a student solely on the basis of roll number is not enough, because there may be many classes in the school and each one of these classes may be having the same roll number. So to uniquely identify the student in such cases, we have to say something like that, class 8 roll number 6. So here class 8 plus roll number 6 constitutes the composite key, that is two keys come together, two characteristics come together and form the key, which is the composite key, so that we may select a particular or recognize a particular student. Next is normalization. It is the process of organizing data in a way that minimizes redundancy. Redundancy means duplicacy and ensures data integrity. It involves breaking down large tables into smaller related tables to eliminate data anomalies. Next is integrity constraints. Integrity constraints are rules that define permissible values and relationships within a database. Constraints specify rules or conditions that the data must specify. Examples of integrity constraints include primary key constraints, foreign key constraints, unique constraints. They ensure the consistency of data and prevent invalid data from being stored. We take the example of foreign key constraint. When an order is placed and order is recorded, then employee ID has also to be customer ID has also to be put in the database while recording the data. while recording the order. So when we are entering the customer ID who has placed the order, the DBMS system ensures that the customer ID which is being mentioned in the order ID is actually existing in the database. That is, it actually exists in the customers table. That is, the system or DBMS system will not allow that an invalid customer ID is mentioned in the order table. That is, we are not having, say, customer ID 1234. We are having only the customer IDs up to 1000, and the DBMS system will not allow to place the order in the name of customer ID 1234, which is actually not existing in the customers table. In the same way, there are other unique constraints. We take the example of unique constraints. Suppose there is a bank where customers come for opening different type of accounts, say saving account. Suppose 2000 accounts have been opened till date, and now another customer comes, he opens his account. Now the DBMS system will ensure that this new customer is allotted another unique account number which has not been already allotted to another customer. That is, this system will allow him 2001 because 2000 numbers have accounts up to 2000 have been already allotted, and the system will not allow that any number between 1 to 2000 is allotted to another new customer. This is the unique constraint. They ensure the consistency of data and prevent invalid data from being stored. That is, these type of integrity constraints ensure that there is proper data is saved and invalid data is not stored in the system. Primary key constraint ensures that each value in the student ID column is unique and not null. Here you can see that all the student IDs are unique. No ID is similar to another one. Foreign key constraint ensures that each order is associated with a valid customer. Here this is the primary key. Here it is the foreign key. Both these accounts tables are related with one another with the help of primary key and foreign key. So foreign key constraint ensures that each order is associated with a valid customer. You can see that this is the customer ID which is mentioned in the order table. So this customer ID is existing in this customer base, customer ID base. That is the customer table. This ID is existing. If you say that there are only customers which are up to C65,000, up to this data, up to this customer number, customers are existing. Customers are on the roll of the particular organization. If while placing order, you the employee of the organization mentions the customer ID, say as C67,001, the system will not allow the same because no proper record of the same, that is the no record of the same will be existing in the customer table. That is, no such record will be available in the original customer table. So the system will not allow such type of invalid data to be entered in the system. This is the foreign key constraint. Next is data integrity. The relational model enforces data integrity by adhering to certain rules, such as ensuring that each value in the column is of appropriate data type and foreign key references are valid. It means that we have already mentioned that when we are talking about the tables, in the case of say employee id, if the ids are in the form of 1 2 3 4 5, all the ids will be in the similar name, that is we will not be able to enter text here. If we are talking about name, the same will be in text, say Mukesh. Here we will not be able to enter 1 2 3 4 because it will be in text base and not in numbers. So each value in the column is of a appropriate data type. Next is structured query language. It is pronounced as SQL or sometimes SQL. It is the programming language used to interact with the relational databases. SQL allows users to create tables, retrieve data from tables, insert new records, update existing records. That is, it helps the user, structured query language helps the user to do various types of works and perform various operations in the relational databases. Now comes the ACID properties. We have already discussed about the 4 ACID properties of DBMS, that is atomicity, consistency, isolation, durability. The relational model supports the ACID properties which ensure that the reliability and consistency of database transactions. These components define how the data is structured, stored and managed within a relational database system. Relational database model is a very powerful way of organizing data. Relational model is easy to understand, easy to use, and it is very efficient for storing and retrieving data. This model has become most widely used database model in the world. It is the foundation of many popular database management systems such as MySQL, PostgreSQL, and Oracle database. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.